Before I get started with the tutorial, I just want to say that I added another bullet image to the folder. So if you don't have this image, you can download it from the GitHub, but you don't really need to. I just added it because I thought it looked a bit better. So here's where we left off from last video. And the first thing I'm going to do is remove these rectangles. So I'll just comment that out because we don't need to see it right now. So in this video, we're going to implement the shooting. So the first thing that we need to do is change the user input function, and what we're going to do is we're going to add another if statement. So if the user presses the space key on their keyboard or presses the left mouse key on their mouse, then we want the player to be able to shoot. So here in my user input function, underneath this last if statement, I'm going to create another if statement, and it's going to be checking if the user hits the mouse key or the space key. So I'm going to type if pygame.mouse.get_pressed equals, and here I'm going to pass a tuple of 1, 0, 0, and this means that the user hits the left mouse key on their mouse or the user hits the space key. So all keys pygame.k_space. And if the user hits any of these buttons, then what we want to do is we want to change a variable called self.shoot to true. So I need to create this variable in our init method. So underneath here, I'm going to write self.shoot, and this will initially be false, but if the user hits these keys, then we want to change this to true. So self.shoot equals true, and we're going to add an else statement, and if the user is not hitting any of these keys, then we just want self.shoot to be false because the user is not shooting. We're going to use this self.shoot variable later on, but what we're going to do now is we're going to call a method called self.is_shooting, and now we need to implement this method in our code. So let's implement that function before our move function. So def is_shooting, and it will just take one argument, which is self. So in this function, I'm going to create an if statement. So if self.shoot_cooldown is equal to 0, then we want to be able to shoot. And what this variable is it's basically adding a delay between each bullet, and if we don't have this variable here, then the user will just be able to shoot a bunch of bullets at once. So we don't want that to happen. We want there to be a delay between each bullet. And here in our update function, what we want to do is if this cooldown is greater than 0, so if self.shoot_cooldown is greater than 0, then we just want to decrease that. So self.shoot_cooldown minus equals 1. So we need to create this variable shoot_cooldown in our init method. So let's go up to that, and let's just type self.shoot_cooldown equals 0. So how this variable works is that the user is only allowed to shoot if the cooldown is 0, and if it's not 0, then what happens is in our update function, which is over here, it will just constantly decrease, and then when it hits 0, the user will be able to shoot. So let's finish off our isShooting function. So inside this if statement, what I'll write is self.shoot_cooldown equals 20. So we're resetting the value of the cooldown to 20 because the player has just shot. And actually we'll just create a variable called shoot_cooldown in our settings file. So let's go to our settings file, and I created a new section here called bullet settings, and I'll just write shoot_cooldown equals 20. We'll actually finish this function off a bit later, so I'll just write finish off later. And what we're going to do for our bullets, we're going to create a separate class so that everything's organized. So underneath the player class, I'll just create a new class called bullet. And this is also going to be a sprite. So I'll write pygame.sprite, and the second S is with a capital S. And for our constructor, we're going to write def__init, and it will take self, and it will also take x, y, and an angle. So x and y is just the position of the bullet that we want to spawn it at, and the angle, we need to know that because we want to shoot in the direction that the player is facing. Next, we need to type in super.__init, and we need to write that for all of our classes. Next, we want to create the image and rect attributes for our bullet. So we do have an image for our bullet in the bullet folder. So what I'll type is self.image equals pygame.image.load, and the folder is called bullet, and the specific image I'm going to use is called 1.png, and don't forget to .convert alpha this at the end. So I was playing around with this earlier, and we need to scale the bullet up so it looks big enough on the screen. So what I'll type is self.image equals pygame.transform.rotozoom, and we want to transform the image, so self.image 0, because we don't want to rotate it, we just want to scale it up, and we want to scale it up to 1.4. Or you can play around with this later, but actually we'll create a variable in our settings file called bullet_scale, and we'll write bullet_scale equals 1.4. Next we want to create our rect, so we'll write self.rect equals self.image.get_rect. So this just creates a rectangle around our image, and we want to set the center of the rectangle, self.rect.center, to xy. So we'll just write x, y, and we're getting these x and y variables when we create our bullet, an instance of our bullet class. So we're passing it in to this init method. We will also initialize our variables, so I'll just type self.x equals x and self.y equals y. The next thing we want to do is type self.x_vel equals, and I'm just going to leave this blank for now, and I'll also write self.y_vel equals. So we need to create variables for the horizontal and vertical velocities, and we're going to do this by using trigonometry. So if you imagine that this is the player here and he's facing in this direction, then this over here would be the horizontal velocity, and here we will have the vertical velocity. And let's just say that we want the velocity to be 10 for the bullet, and here's the angle, and we already know the angle. Let's just say it's 45 degrees, and this is the angle that we're passing into this init method. But what we need to do is we need to figure out a way of calculating this horizontal velocity. So what we can do is we realize that this is the opposite to the angle, and this is adjacent to the angle, and this is the hypotenuse. So we have the adjacent and hypotenuse, so we have to use cos. So cos of the angle, cos 45, equals adjacent, so that's what we don't know, x over 10. So if we want to work out what x is, we just do 10 times cos 45. And for the vertical velocity, it's a similar process, but we just use sine. So for the horizontal velocity, what we will type is math.cos self.angle, and we need to turn this into radians because this math.cos method, it uses radians as the angle. So I'll just type 2 times math.pi divided by 360, and I'll just get rid of these annotations for now. So next what we need to do is times this by the speed. So we said that that would be 10, but I'm going to create this in a separate variable called self.speed, and we'll just create that before here. So self.speed equals bullet_speed, and we need to add this to our settings file. So I'll just type in bullet_speed equals 10. So let's do the same thing for our vertical velocity, but instead of using cos, we need to use sine. And we also need to initialize this angle variable, so I'll just type in self.angle equals angle. And that's basically everything that we need for our init method for now. So the next thing that we need to do is create a function for the bullet movement. So I'll write def bullet_movement, and that will just take self. So what we want to do in this function is basically update these two variables here, so self.x and self.y, and this is the position of the bullet. And then what we want to do is place the rectangle of the bullet at that position. So inside this function, I'll just type self.x plus equals self.x_velocity, and self.y plus equals self.y_velocity, and self.rect.x equals int self.x, and self.rect.y equals int self.y. The reason we need to convert these values to integers is because the x and the y attributes of the rect object in Pygame must be integers, and right over here they are floats, so we just need to convert them to ints. We also need an update function just like our player class, so I'm going to write def update self, and here we just want to call the function that we just created, so self.bullet_movement. And before we continue, I realized that we need to create the groups for our sprites. So right now we have a player sprite and a bullet sprite, and we're going to create a group called all sprites group, and this will contain all of the sprites in our game, and we'll also have a bullet group. So let's do that next to where we create the instance of our player. So I'll just type in all_sprites_group equals pygame.sprite.group. And we also want to create a group called bullet_group equals pygame.sprite.group. Next, we need to add our player and our bullets to these groups. So let's first add this player instance to the group. So to do that, we just type in this. So all sprites group.add player. And to add our bullets to our group, we need to go up to where we created our isShooting function. And we need to finish this off. Okay, so firstly, we don't need this comment anymore, so let's remove that. And the next thing we want to do is create an instance of our bullet class. So anytime the player is shooting, then we want to create a bullet. So we just type in self.bullet equals bullet. And our bullet class takes in 3 arguments, an X position, a Y position, and the angle. And the X and the Y position is basically wherever the player is right now, and we have a position variable for the player up here, so it's self.pos. So we're going to use that. So just before here, what I'll type is spawn_bullet_pos. So this stands for spawn bullet position, and that's going to be self.pos. So inside our bullet class for the X position, we're going to type in spawn_bullet_pos, and in square brackets we'll put 0. And that will get the first element in that tuple. And we do the same thing for the Y position, so spawn_bullet_pos, but now we want the element at the first index. And for the angle, that's just self.angle. Just like we added the player to the all sprites group, we also want to add the bullet to the bullet group as well as the all sprites group. So let's do that here. So bullet_group.add self.bullet. So we're just adding it to the group, and we're also going to add it to the all sprites group. So all sprites group.add self.bullet. Okay, so we're almost done. All we need to do now is just draw our bullets to the screen. So let's go down to our while loop. So over here, we are splitting the player image to the screen and we're updating it. But now what we can do is we can just update the all sprites group and just draw that to the screen as well. So let's get rid of this player.update and screen.blit line. So over here, we can replace that with all sprites group.draw screen. And this is really good because now we're just updating and we're going to be drawing everything to the screen in one go. So I'll also type all sprites group.update. And now let's run that and let's see what that looks like. Okay, so it doesn't look great. It looks pretty bad. So what we need to do, well, let's see if you can figure it out. So what do you think we can do to make this game look way better? And I'll give you a hint. It's something to do with the settings file. So all we need to do is go to our settings file, and this bullet speed variable should be way higher. So let's try 50, and let's try running that again. Okay, so that looks way better. So there's still an issue. So right now our bullets, whenever we shoot, they're just flying off and they're never being deleted. So even though I shot this bullet like 2 seconds ago, it's still flying, but I can't see it. And this is really bad because if you keep shooting and you play this game for a really long time, then it might cause some lag. So we need to actually delete these bullets after they've traveled a certain distance. We also have another issue, and that's that the bullets are coming directly from the player's head. So we need to create some sort of offset so that it looks like it's coming out of the gun instead of the player's head. Okay, so let's deal with the first issue, which is that the bullets need to disappear after traveling a certain distance. or traveling for a certain time. So let's go to our bullet class, and we're going to create a new variable called self.bullet_lifetime, and we'll set this to 750 milliseconds. But as always, we'll just create a new variable bullet_lifetime, and we'll put this in our settings file. So bullet_lifetime equals 750 milliseconds. So what we're going to try and do is delete the bullet if it's been on the screen for more than 750 milliseconds. So let's create another variable, self.spawn_time, and this will be pygame.time.get_ticks. And what this does is it gets the specific time, so it gets the specific time that the bullet was created. Okay, so now down in our bullet movement function, what we can do is we can add an if statement. So if pygame.time.get_ticks minus self.spawn_time, and I'll explain how this works in just a second, is greater than self.bullet_lifetime, then what we want to do is just kill the bullet, so self.kill. So that just removes the bullet from the screen. Okay, so to understand how this works, we need to understand how pygame.time.get_ticks works. And that's basically a timer. So whenever I start the program, then there's a timer that's running. And that might be 5 seconds, it might be 10 seconds, whatever it is. What happens is that whenever we create this bullet, we are storing the time that it was created in this variable. And then later on, we're subtracting that time from pygame.time.get_ticks. So basically, this calculation, it gives us the time that has passed since the bullet was created. And if that time is greater than the bullet's lifetime, so let's say 750 milliseconds, then we want to remove the bullet from the screen. Okay, so now let's see if that works. So we should be noticing that the bullets are disappearing. Actually, we might need to adjust the bullet lifetime so that it's a bit more obvious. So let's go to our settings file, and I'll just change this to a very short lifetime. So let's say 100 milliseconds, and let me run that again. And yeah, as you can see now, after 100 milliseconds, the bullets just disappear from the screen. But for me, that's a bit too short. So I'm going to change this to 750, but you can choose whatever you want. So let me just change that back to 750. Next, we're going to fix the last issue, which is that the bullets are coming out of the player's head. So what we need to do is we need to go to our player class, and I'm in my isShooting function. And what we need to do is we need to adjust the spawn bullet position variable, and we need to add on an offset to it so that the bullets look like they're coming out of the player's gun instead of the player's head. So to create this offset, what I'm going to do is I'm going to go to the init method of the player class, and I'm just going to type in self.gun_barrel_offset equals, and this will be a vector. So I'll type in pygame.math.vector2. And here I'm going to put 45,20 as the offset. And I played around with these values earlier, but as always, we're just going to create these in separate variables, and we're going to put them in our settings file. So gun offset X and gun offset Y. And let's go to the settings file. For our player settings, we'll just put gun_offset_X equals 45, and same thing for the Y, but it will be 20. Now let's go back down to our isShooting function, and over here we can add on the offset. So I'll just type in self.pos plus self.gunBarrelOffset, and we need to rotate this, and we'll just pass in the angle. So the reason we need to rotate it is because the position that the bullet needs to spawn at depends on the angle that the player is facing. So let's run the code now and let's see if it works. So yeah, as you can see, the bullets are coming out of the gun now, rather than coming out of the player's head. So everything to do with the shooting mechanic of this game is working properly now. I'm going to leave it there for this video, guys. So if you enjoyed it, please don't forget to leave a like and subscribe. And if you have any comments, then leave them down below and I'll be sure to read them. And as always, all the code and the assets will be in the description below. And I'll see you guys in the next one.